All right, guys, let's continue. So now what we're gonna do, we're gonna continue with the Echat server. After we have our exploit for R, the client-side exploit. So as I just mentioned, it's quite similar. It's gonna be quite similar for because it is a structured execute handler type of exploit. So the main difference is gonna be the use of a socket. I have it here. That's gonna be the exploit. And let's also divide it. Let's divide it into steps. So that this is a full exploit, but we're gonna also create a POC for it. So we're gonna also save it here, but it's gonna be a POC. Check it server. Okay, so we have here. This one is stuck with the fact that we run the calculator on it. There you go. Okay, so if Echat server, this is done. Program's running here. Let's confirm this working properly. Oh, it's not. So that was a good test. Let's check why not it's working or it's not working. So if I go to CMD and do ipconfig, there now should be popping up. That. So if I do net stuff, for example, -A, I can see if it's well, I know already because it's not bind the port. So, but so for some reason also let's just reboot this machine. Of course, if the port is not bind and it's you don't have a listener there, then it's not gonna this plug is not gonna work. So that's the first thing that you need to check. We're gonna run it locally from the same Windows machine, but because it's a remote exploit, it can be executed from your host if you want, if you are building the exploit, because it's remote, right? So let's try it again. Double click on it, try it, and then we're gonna click on go. And for some reason, it's not binding. Oh, well, look at that. It's not running, so it should run start. That was weird. So now it should go. That was an oops. Okay, now it is running the server. Click go, and then it is working there. So let's do CMD. I'll be config matches on my VM, the one that is using here. If I do next step -A, here I can see these ports. So 80 and 443 are binded. Those are these two listeners. They are on these two ports. They are being used by the Echat server app. So that's correct. So now we can start with the exploit. We choose copy the exploit into a new one. So this one, so this one is a copy. So we're gonna do pop Echat basic. I'm gonna try to do the same. I'm gonna start removing some stuff from here. So we don't want to have the shellcode. The buffer size we know already is to 270, say 775, but let's also remove that because we know the buffer size, but if we don't, it's something easier. Maybe choose to add more A's, right? I'm adding 0 to this. So now, if I'm not mistaken, we are gonna to overfill the buffer with our A's. So instead of going into the structure, the SE, and then jump into the doing the short jump and going into the stack, into the knobs, and then running our shell code, is going to just overfill the buffer, the stack with A's. All right, so we need to run this. Gonna attach into the server. Continue the execution. Just gonna show you there, and then I'm gonna explain you how it works on the in terms of the socket. Run it. Once it's fine. And that's arrays. Now always try to jump into A's because we overflow everything with A's. And if we go into this SE, structure exception handler, we see that this exploit again is a vanilla type exploit. The AI execution point can be overflowed, but also the structure exception handler, same case as the other exploit, the other program, basically, we are able to override values here. So how it works? So that's the buffer size. If we wanted, we can do it. I think we should do that. First, we're gonna use the stickling pattern and then look for how do we get those values from the stickling pattern as a recap exercise. So we're gonna do that right now. But first, let me explain you how this socket works. So we are using the string, sys, socket, and struct. Instead of changing the values of, doing the values in reverse, or here we are using struct and packet from the memory address. So this memory address is easier to read. I mean, it doesn't matter, but I think this is way nicer than reversing the values as we did on this one. So here we have this, and then we reverse it. But if we use struct, so if we do here import struct, and then we want to use this, we can choose to this. So that's way better. I mean, easier to read, easier to understand in a glance. Then the buffer size, of course, that we established it here that our buffer size is going to be 3000. Here's with 775. Then NOPS for the debugging purposes, we have this, we can remove it. So that's basically an entry, a breakpoint, CCCC. So if we add that, then the program is gonna stop. It's gonna stop. So if we add debug into the buffer, so if we wanted to add that is after the shop champ. So remember we were stopping the execution there. So if we do shellcode instead of choose shell, we do debug plus that. Actually, if you want, I can show you here with these small changes on R. We can say like that, optional breakpoint. So it's gonna not like that, but after the knobs. So it's gonna be after the knobs, it's gonna break just before running the shellcode in the case of R. So let's run that one. Crash this. Of course, we need to attach it. If I continue the execution after the pop-up red, but not choose continue the execution, so like that, jumping into the ops. And if I continue execution here, what's gonna happen is that I'm gonna read that breakpoint. Yeah, there you go. So that's our breakpoint. And then now, of course, if I continue the execution after the breakpoint, if it, well, of course, if it was aligned, it will, that was not aligned, it will get us into the shellcode. But that's a good way of breaking into the app, like forcing it. So that's optional, of course. And you don't want it. I mean, for testing purposes, but for if you want to run it, you have to remove it, of course. Otherwise, it will not be. Well, it's not going to be useful because it's not going to be aligned. Or if you align it, then you have to run it inside the shellcode. But for testing purposes, it's quite good to have it. So let's run it without it. That's our calculator. So that's how you use, how you force a breakpoint into an application when you have it, of course, when you have code execution. And that's how you use Swap. So this one chat server again. So this chat server. Then we're gonna attach to it. Or you can load it right from recent files and then look for it. So now it's running. Let's keep on explaining this. So this is a optional entry. The shellcode itself, that's a calc. Of course, you can change the shellcode to anything you want. And then here we are constructing the buffer. So the buffer is chunk plus the short chunk, the SE, so the new value of it, the knobs, and then we calculate the knobs by the amount. So how many knobs is by the amount of the buffer size minus the shellcode, the length of the shellcode. So in this way, you can change the shellcode dynamically. So if you change for another shellcode, it will be fine. It should be, the shellcode should be able to fill the amount of the buffers, but the buffer is quite big in this case. We're going to remove the debug, and then we have the shellcode. And how do we send this buffer? We need to do a get request. That's why we are using socket. And we are constructing here the request, basically the string that we're going to send as request on the socket. I have two versions of this exploit. On the first one, we open exploit pack. I have two versions of it. On the first version, I'm using URL and lib. So in exploit pack, for Echat. As for the newer version, that's this one. So here, this is an exploit I developed myself, and here I'm using URL lib, HTTP lib, and constructing the URL here. So I'm sending the buffer. So this is the trigger. So when you go into chat, username, and then a long one, and then plus this, and actually we can try it manually. This, so you can see it manually. And then sending the buffer, and we are sending this using URL lib. So create a connection, HTTP lib, connection host port. The type of request is get, and then the URL is this, right? And then the stuff. Here, I did it using socket. It's basically the same, but I am constructing this string plus the buffer. Then these are just the regular values that you need to send for the header of the get. That's user agent, host. That's I'm feeding the host and port from here, and I'm taking as here we can also use it as an argument, but instead I choose hard coding the value of my VM host plus the port, that's port 80, and then as a value of the header and the referrer I can choose that is gonna be also the host, and then connection keep alive, and that's it. Then, of course, I create the socket Echat, using the library socket, calling socket, the type of socket, and how I'm gonna interact with the socket, so the string, connect to that socket, using the host and the port, and then I send through the socket my values. That's basically the bytes of the string, and then choose closing the socket, right? But as I should say, let's try to also do it manually. So run the program. Now should pop up. There you go. Try it. There you go. And if we go here, and if it's running, it was not running. Now it is. There you go. And now, if I go to this, that's gonna be 172, 172, 16, 150, 129. Trying to do it manually here. And then I'm gonna call this, remove this, and then buffer. I'm gonna do it manually. I'm gonna add some A's. How many A's? More than 270, yeah, something. So let's stick it on the terminal, because we already, remember, we created 3000 A's using Python, like that. And then we need to remove. There we go. And now, manually, we have sent all these A's. And manually, we have sent, we have also written the exception handler and triggered the buffer overflow from Microsoft Edge, not from the Python itself, right? So now what we're gonna do, we're gonna close Microsoft Edge, restart, run it again, run here, try it, run it. Now it's running here. What we're gonna do is gonna choose, like with the other exploit, we're gonna replace the A's for a pattern. So you can see it working as a recap. So let's create a pattern of 3000. I'm gonna go here, set the, so first we are setting this working directory, and then we're gonna create a pattern, ERC minus pattern C 3000. We go to log, it's already there. We are going to go into the training folder. This is the second pattern that we create. That's basically just a copy of the first one. Yeah, and if you remember, it should be something here on this exploit. We already have it as a string. Yeah, here. So we can choose copy it from the other exploit. And we're gonna go into this exploit, and we're gonna add it here. Fix the indentation like that. And let's replace buff for replace or pattern. I also replace this buffer. There you go. Now we have pattern, and instead of just sending the whole buffer, we're gonna say that we're gonna comment this and send buffer equal pattern, just like that. Oh, actually, to make it even simpler, is we are gonna just send the pattern, right? Like that. Actually, we could also send the pattern manually because it's a string. We could do that as well. Should we do that? I think we should do that instead of sending it to here. I think it will be way easier to comprehend and to reproduce. So I'm gonna leave like that. What we need the pattern, but we need to make it a string. So let's copy this. Enough. I'm gonna put it here, and we need to make it a string. So let's let's make a macro so it's quicker like that. Okay, and now repeat the macro. But we are missing something from the macro. We need to have it as a string, full string. So new macro, stop recording. Until there. Now I have choose along, along. And of course, the last bit. And now we have a very long string as our pattern. We go here. And then from here, what we're gonna need is the explosive one. Yeah. So we need the URL. Like that. And that's it. And if we did our copy paste correctly, then we can go into here and uh, this, that, that should be it. And now we have the crash with 3000 as a pattern. And then we can, from here, we can do ERC. We need to do find the pattern. So ERC minus find here and NRP. There you go. Now we need to wait a few seconds. Now it's looking in memory. There you go. So that's our pattern. That's what has been found. In the world, it should be buffer size. And replace it all buffer. So buffer size, that's correct. And now we have 217. And as you can see here is exactly what we needed. So actually should put it here. So it's easier to understand. And also put here manual, yes, the pattern, manual, test, or pending request and trigger with 3050 pattern. There you go. And if you want to copy it, if you want to do it, I will share with you. Oh, it's too long, of course. 3000 A's cannot be shared in the chat, but you can create it. Now you know how. So to make it easier for you, I can also type it on the chat like this. Address process buffer. Um, and there you go. So you have to replace your IP, of course, for the one you are using, and the buffer for the cyclic pattern. Okay. And now we know that where this 217 is coming from. Of course, the EV08 is the same as with the other exploits, choose a short jump. Then from here, we are using from this library, this pop-up red. In this exactly in the same place after we have triggered buffer overflow, we can do ERC minus SEH. And now we can either use this or replace it or use something else. So we can use any of this, but preferably we will use one that is not from your Windows, but that belongs to a binary. So it should be somewhere here on the top. Look for it, the binary to be somewhere there. And then pick one, of course. We are using one from SSL EA 32.dll. That's basically a pop-up red, but it is doing ASP, pop AC, and a SAE. But in my case, if I use any of this, it will work as well. And we are used because remember now because on this exploit we are using struct, we are also changed it for the other one. We don't have to reverse the Indianness of the memory address because we are using struct and struct is doing that for us. The buffer size here, the nodes LED, the debug, we can comment it because we are not using it. This is optional. The shellcode is the same shellcode, is open a calculator. Then we construct the buffer here. It's the chunks that we have here, 41 plus 217. So we can reach the SEH, the structure exception handler. So that's why we are using this amount. Then the short jump, then the structure exception handler itself, that is gonna be a pop-up red, plus the knobs, the amount of knobs. That this is like this. So it's the knob by the buffer size minus the length of the shellcode. And it's remember I made it this way so you can change the pop calculator shellcode for something else, like a reverse shell or something like that, more useful. And then of course at the end the shellcode. Then we are sending this over this to a socket to this IP address. So let's run it. Let's see it run. And now like this. Run the server. There you go. And now pop Echat basic should be this one. We double click on it, and now we choose run it. Let's see if we went there or not. I'm still in my pattern for some reason. Let me check out. Oh, it might be this. Okay, so right, okay, run the server, run this. See if we have something wrong and check that this there's an error somewhere. Grammar escape. And let me run it from my console so I can get the error. But this is a Python error. This is not that. Let me check. Mhm. I complaining about that. That's weird. No. I am missing something, guys, but there is an error in your program. Invalid escape. When I escape, I escape nothing. That's so weird. Let's because we luckily I think we have a copy here. So this it should be exactly the same one, except for our comments. But what I'm missing here, I don't know. Oh, might be this. No, that shouldn't be it. Let's run this one. Oh, well, that one should work. Right now I'm triggered. I want to know what's the difference between these two files. And it's not showing me any line. Um, that's weird. Um, there is an error in your program, invalid escape. So where I'm using that to escape, what I understand from that is that it's something like that, right? So it's escaping a value. And it's not this. Now, let's see, start removing some stuff. Remove all the comments. So yeah, so it's not that. So this we change, and it's also not that. Uh, here's error. There is an error in your program. Invalid escape. But it's a Python error. It's not the so weird. No, no, it's not showing. So in any case, well, in any case, we have it here. Let's move over our annotations. Jump over SEH, and then we say, okay, that was it. Pattern, knobslet, pattern, knobslet. Debug, we are not using it. And we say entry optional, it's more clear. Then buffer, we also change that to host. And then that's it. Yes. Actually, see if it's working. And it's working. I don't know, guys. That's so weird. But the other one has something there. But if I run it, you still get error. So let's just use this one. I'm, I'm gonna keep this one. But I can check later what's the deal with that one. But still, this one is it has no difference. It should have a difference, but something I'm missing it. But for the exploit sake of it, it has some difference. So we're gonna read one. Yeah, I will do that. Run the program. Click on and then try it. Okay, now the server is running. Let's check it is running. It is. Okay, we have POC echat.p. Let's double click on it. And now, because we are in the debugger, it should have raised the access violation. There, we continue. There you go. So that's our first access violation. Continue, and then we have the calculator because we went into Echat. We can also, if you want to debug it even further, can run it again, and we can follow the execution instead of just running. Right? Like that, run it, and now we're gonna follow the execution after we reach here. This is what we wanted. That's our short jump on our SE here. Our add pop add red. That's basically the same as pop red. So we're gonna now we need to continue execution so we can reach the structure exception handler. There you go. Access violation, and now we are here. Continue, and now we can continue the execution and choose follow, and there we follow the stream of the and we get the calculation. Let's do one more. Let's do it one more time, but this time without the debugger in the middle. And now this is chat server. Try it. Run it. Run the exploit. And we go. There is a calculator. All right. Now that we have both exploits running, I also gonna keep the one with the Python error. I'm gonna share all of this with you guys. So all these nodes and the exploit codes. Let's take a look into exploit pack and how do we import this into exploit pack. Of course, most of these exploits, they can be found in exploit pack itself, as I should show you. If you look for Echat server, here you find my exploit for Echat server. from back in the day. And that exploit, I was using the HTTP lib, but the HTTP lib changed. That's why, well, on Python, if you use the old version, it will work, but on the new version, it will not. That's why I changed it into a socket to make it more universal. And from here, if you are creating your own module, you can, from exploit pack itself, of course. Let's say we want to add here a pattern, say pattern. You can create a pattern here, add pattern, or check the offset. You can also add path charts, add the shank code, or let's say the knobs. Or if you want to replace, let's say I want to replace the shell code and I want to use this one, but I want to use shell problems. You can control space, and then you can directly select from here a different shell code. That's, for instance, as a minimalist pop of a calculator. That's better. There is also a list of shellcodes here that you can use for different operating systems. There's way more bigger list of shellcodes here if you want it as well. So let's say Windows 86, and one of these ones was the one that I used for the exploit. But of course, you need to respect the size of, for instance, this one, download execute Microsoft exe, or if you want to start the Explorer, or I know, you have to pick one. But of course, I was mentioning you need to respect the size of the buffer. Because on the shellcode itself, it's basically your code, the search box or something like that. You need to respect the size of the buffer, right? So it's not like you can choose whatever you want. Your shellcode needs to be able to fill between those boundaries. If you put too big of a shellcode, then the program might be corrupt. How do we import an exploit? How do we create an exploit, the exploit path? Click add module if you want to add a new module from here. But you can also do it manually. And from here, you can import the module. So we can here add new module or import the module. And let me show you here on the VM. I'm going to show you with the latest exploit for that we sent for total security AV. The password should be somewhere here. Let me pause the share to copy the password. One second. I can show you the file extracted and then the structure of the exploits. Go here, password. Oh, I have it extracted already. There you go. All right. Oh, I need to share, of course. Reset share. Here. There you go. Okay. Okay. So how this structure is the structure? So here for this exploit, for total security exploit, you have the XML file. And then the code itself. Oh, one second on the chat. Let me think. Office email. Yeah, it's gonna be. I think we have around one more hour to go. And then of course, guys, we're gonna share all these notes. These the exercises as well, and all the notes and the documentation that we have online. It will be shared later on, plus the recording. The latest one is not the malware bytes. It's I think it's a total security 360 exploit. That's the latest one. So if you don't have the list of the latest one, you can email us at support@exploitpack.com and we can send you all the most recent releases. But over the structure, I'm just picking up on this exploit because I had it here. But let's discuss the structure of how it works, which is quite easy. So you have your code here. So that's the code of the exploit. Or this one is also a Python file. Doesn't have to be Python. It could be anything here. But remember, if it's quite important for because exploit is intelligent enough to pick the script. Otherwise, it will use Python as default or the interpreter that you choose as default. But otherwise, if on the header you have the is it here? Let's see. If you have the environment set to what's the binary that is the script language that it needs to use, then it will try to use that one. Otherwise, like on these ones, on these exploits, it will just try to use the default one. It will not read the code, but what it's gonna read is the environment. So it's gonna read this, right? So if you have user being Ruby, then it's gonna use Ruby, right? Otherwise, it will use Python. So that's the only thing you need to know. And well, no, not the only thing, of course, the system arguments. So it's gonna be target, port, so it's one by one, target, port, path, local name, shellcode, special arguments is needed, and then the shellcode type. And then the shellcode type, if you use the skeleton, as I'm using here, is like this. So R for remote, E for only execution, C for client side, and L for local execute code, right? So it depends on what you wanted to use. Remote shell, execute code, and so on. If you have those, then if those are set, then you have it listed here. Those values are coming from the XML file, so not from the code itself. And on the XML file, if I open the XML file here, what you will find on this exploit is the code name. So here should be the same one as this one. So code name 360 total.p. And then total security 360 should be the same as the XML file. So it's gonna go there. The platform, in this case, because it's one of the 0 days, the type is client side because it's the client side exploit for total security IB. It's not remote, doesn't have a local port, shellcode available, it's only execute code. The author, the date, and if there is a vulnerability under CVE, and then of course the description and the target. And all of this can also be edit or created from on this case, I'm editing this exploit from here using the wizard editor for this exploit, or you can set it up manually, of course. Or if you added the exploit itself, you can just type it here, and then it will create the XML file for you. If you click on next after you set these properties, and the module description is going to ask you for the code and the code is gonna come here. If you make a zip file of that, then you can go into File, Import, and then you can browse for that zip file, and then you can import it here. Let's say you make you made a Echat server exploit yourself, or the R exploit. Let's say, hey, I want to share that exploit with my colleague because he's doing a pen test and he needs to exploit that particular program, and you have the exploit. You can do it, and as well you can export it. You can back up your exploits. You can do backup exploit, and then it will create a backup of all your exploits, and then you can share that folder of your exploit backups, and then import it. And that should be it. It's quite easy, to use. Now it's gonna take some. It will take some time to back up the exploit. Now it's done, but it will take a few minutes. Then after that, after you have your own exploit, let's say I'm doing a pen test and I build this exploit for SEH, structured exception handler exploit that is abusing this vulnerability that you discover. And remember, you can also use exploit pack to do a quick check on applications. For example, the TCP buffer, if we have set it up on here on the for the Echat server, and we run it here, what we could have done with exploit pack is to send a custom to the port IP to that particular address 16 something on my VM, and then run it, and then we could have discovered that by yourself using the TCP buffer is overflow. That's quite handy because then you can just click a skeleton and it will make the exploit for you in Python. So that's something you can do doing a pen test, and then share export that exploit, share it with your colleague, and so on. How you can automate that process of running that exploit? By using autopound. So let's say I will check for this VM, config. So that's my IP, 150.179. If I go here, oh, sorry, 172, 60, 150, 179. The attack type is by open ports, and the shellcode type that I want to try to run is execute code. So if I run this, what's going to happen? You will hear one new autopound instance started. Please wait. It's gonna first run mmap on. I'm gonna cancel it because I don't want to crash that machine. But it's gonna run autopound first on. It's gonna run autopound. Mmap first on that machine. It's gonna take some minutes to run mmap, and then based on open ports, or this is the output of from mmap by service or references or whatever it found. So typically it's open ports. It will then pick from all your exploits. If you have your custom exploits as well, it will try to pick that all the exploits that are using that open port or affecting that port, or by references, depending. And then it will choose if you have on your exploit selected execute code or remote shell, because it has to be remote, otherwise it will not work. It will try to choose that shell code. In the case of Echat server, there is a remote shell and also execute code. So if you pick execute code, in this case, it was gonna pop up the calc. And if you choose remote shell, in this case, it's gonna choose a shell code. It's gonna replace that shell code with a shell code that's gonna create a remote agent for control pack, for exploit pack, sorry. And I'm mentioning control pack because after you have a shell code here, if you have control pack, then you can leverage that shell code into a full control package. You can still use the shell code here with a minimalization of exploit path, but if you want to have full control, I mean, if you want to gather passwords, get access, more deep access into that computer, then you should use something that will give you a full agent access. In any case, all your shell codes, if those are remote or you have run an agent through that, are going to be listed here in the agent connector. But of course, you need to have a shell code is connected to the port that is listening on exploit pack. The agent connection port is 8,000. So your shell code needs to connect back to the port 8,000. And it's going to be a choose a regular shell code. After that, you can upgrade that into a remote shell using this. So if you click here on your shell code, then you can upload it to a remote shell. All right. I think we could cover a lot here, guys. What we're gonna do next? I'm gonna save all of this. I'm gonna share with you the training folder to all the people that's here and also the people that couldn't attend and gonna watch this recording. What I'm gonna ask you is that you do these exercises yourself. So meaning try to go step by step as if you follow along the recording of this video. There's also some material for you to read that we have online is here under documentation exploit development. You have the buffer overflow read here this is for Linux, but also applies to it. And then if you go to exploit development 3, you will have the structure exception handler exploit, and as well a description on what is the difference between a basic overflow, how this works using Mona. In this case, we have used ERC and x64, but it's basically the same. If you want to get into, you can also try it with Mona as well. It's basically the same. So follow this, follow the video, do the exercises, and then after you have it, you can import this exploit into exploit pack. If you have any questions, any technical questions at all, except for the Python one, because I don't know what's the deal with that typo. I'm gonna check on that later. But for the rest, feel free to contact me through Discord or by email. And I hope you have enjoyed this training. I hope it was useful. Yeah, thanks for attending, guys. All right. Thank you, guys. Have a nice weekend.